We're going to be looking at lab 12, which was similar to lab 11. However, in this lab, we are going to be using Nand Gates instead of NOR gates, and we also have the inputs of our R and S switched. That means our outputs Q and Q naught will also be switched. Just like the previous one, we are going to be using Multisim, and then we are going to be coding this in Verilog, and then we will be using ModelSim to form a waveform and analyze that. So first I have our DIP switch and a few things hooked up right here. These are just our inputs, so we can see what is outputting when we flip our inputs. Now I want to paste our gates, so we can hover over place TTL, we can click it, and then we want a NAND gate. So we can just type in 740, and the NAND gate is actually the first thing that comes up. It's going to be 7400, that's the gate code for it. So we'll press OK. We can have any one of those names, and we'll just add it in here. We'll click cancel, and then we can copy this and paste it in here. Now we need to wire this up. So our Q naught is going to be on the bottom, and Q naught is going to be the very back, and then our Q is going to be right in front of it. Now we know that we have some wire going from our Q, the actual input. It's actually coming from our Q naught. So we can wire this in here like this, and then we're going to have the same thing for this Q naught. We have some input from our Q like this, and now our S is going to be the first thing connected right here, and then our R is going to be the second one connected right here. So this is what our circuit should look like, and now we can try testing it to see the truth table. So we'll run it right now. We can see that at 0, 0 we have 1, 1, which is invalid, because, well, if this is Q and this is Q naught, Q is 1 and a naught of that is 0. Well, we can't have 1, 1 when it's 0 and 1. So this is invalid. Next we have 0, 1, so we're going to flip our R up, and then we can see that we have 1, 0, which is exactly the output that we wanted. Now we're going to flip up 1, 0, and this is also the output we wanted, which is 0, 1. And then if we flip up 1, 1, we can see that there is no change. It remains at the present state. And so this is the Multisim, and that is all we're doing for here. Now we're going to go into Quartus Prime, and then we're going to actually code our Verilog in a test bench so that we can demonstrate it in a ModelSim waveform for it. We're going to make a new project wizard. We'll click next to this, and we need to choose our working directory. So I usually like to do this PC, my network drive, the desktop, CP64, and then we'll make a new folder, and we'll just call it lab 12, and then we'll enter in here and click select folder, and then so this is our destination. What is the name of our project? Well, we can just call it lab 12, and so that is the name that we're going to stick with. We'll click next, empty project, next through this. We need to change the family name to Cyclone 4E, and then we're going to type this into our name filter to get this. We're then going to click next. We're going to click simulation, ModelSim, Verilog is selected, and then we will click next and then finish on the conclusion. And then it's going to load us up. We can full screen. We're going to come over to the left and click a new file. We want a Verilog HDL file, so we will click OK to this, and now we're going to be in here. We can start coding for this. To start this off, we're going to have module, the name of our lab, which is lab 12. We have to stay consistent to what we have over here. And then we are going to have our inputs and our outputs. So we're going to have S naught, and then we're going to have R naught. And remember, this is kind of based off of lab 11, where we had S and R inputs. And these are basically just flipping the inputs, because if it's not S, then it has to be R. And if it's not R, then it has to be S. Then we're going to have Q, and then Q naught for our outputs. Next, we're going to deal with our inputs. So we have input S naught and R naught. We're just labeling these. And then we have outputs Q, and then also Q naught. So those are our inputs and our outputs. Now we need to make our actual gates. So the gates themselves are NAND gates. So we're going to type in NAND, we need names for our gates. I'm going to call the top one Nand1 or Nand Gate 1. And then we need our output first. This outputs into the Q wire. So we're going to have Q. And the inputs are S0 and also R0. So we're going to close this and end this line. We're actually going to have a comma here because we want to code another NAND gate. And we can do it on the next line or the same line. We have NAND Gate 2. And then we are going to have our output, which here is Q0. And then we have our two inputs. And two inputs are Q and R0. And then we can end this line finally and come down here and do end module. Now we're going to want to make a new project for our test bench. So Verilog HDL file, click OK. And now we come in here. For our test bench, we're going to have module lab 12. This is the name of our lab. Then we have it followed by an underscore TB, two parentheses, and then we're going to end this line. We need to make code for our inputs, so we're going to have reg S0 and R0 for the inputs. And then for outputs, we're going to have wire Q and also Q0. Again, these are for the outputs. Now we need the name again, so lab 12. This is followed by UUT. And we've coded this before. It's kind of time consuming, so I'm going to copy and paste it into the code that I've done previously, where we have .S0, and then we have parenthesis, and then S0, and then comma, and then we list the rest of them, just like this. And then we would end this line, and this is all in parentheses. After we do this, we need to do an initial begin, and then we're going to have somewhat of a truth table, where we have our S0, R0s, and then we have 0, 1, 2, 3, and 4. And this is with the number 10 back here. So we would just code this out and write this in here, making sure to have all the appropriate brackets. So it'll look like this. When we're done with this, we're going to come down here and we'll do a $. We'll type in finish. We'll end this line. We'll next type in end. And then we're going to type in end module. And so our test bench code should look like this. We'll go back to our actual code. We will click compile up top, start compilation. We're going to click yes to this. And then we need to make sure that we are in our correct destination, which we are. We're going to save this as lab12.v. We also need to save our test bench, so we'll click yes to this. And then instead of saving it as Verilog 2, we want to save it as lab12_tb. And then we click save. It's going to run some tests, and then we'll come back when it's finished running them. Alright, so there is an error in the code. It looks like it was in here, and this is in our actual code, not the test bench. And that looks like because I never ended the line, so you gotta have semicolon right here. Also, I don't have a comma between the Q0 and the Q, so make sure you place that there to separate your actual inputs and outputs. So comma between each of these, and then an end line right here. We're gonna hover over start compilation again. We're gonna click yes so that we overwrite the bad code, and now it's gonna start running our tasks again. Once that is complete, we have to go into our lab12_testbench file and start a compilation for the test bench file. So start compiling this. That way we have both the lab12 and lab12tb compiled. Don't know if that's 100% necessary. I think it compiles both of them, but at the same time when we compile just this one. But just to be safe, I'm going to compile this one separately as well. Alright, now that's compiled, we're going to go over to Tools on the top. We're going to run the simulation tool and click RTL Simulation. After this, a little guy should pop up on the bottom. Looks like a feather. And this is our ModelSim. So we're going to go and full screen this. If our wave doesn't show up, which it doesn't here, we need it to. We need to go to View. We're going to go to Wave. And then our wave will pop up like this. Now, if we click on Work, we can see we only have our lab 12 in here. We don't have our test bench. So we need to go to Compile. Click Compile. And then we're going to go up the directories until we actually find where we stored our files. So I'm going to click compile on lab12.v. We see we have 0 errors, 0 warnings to the left bottom. And then I'm going to compile the test bench, 0 errors, 0 warnings, and we can see it's popped up underneath our work. So we'll click done here. Now we're going to go up to simulate at the top. We're going to start compilation. We're going to click on work. We're going to click on our test bench, and we're going to click OK. We have 0 errors, 0 warnings, which is also great. So we're going to hold Control or Command, and we're going to click all of these, and then we're going to bring them into the wave right here. After we do this, we can go up to where it says 100 PS. To the right, it says Run. We'll click Run. We don't want to finish just yet, so we'll click No. And then it'll bring us back to our code, but we'll also have our wave right here. We're going to zoom full. And then this is what our diagram should look like. So when our inputs are 0, 0, our output is just 1, 1. S0 and R0 are 0, 1. We get 1, 0 for our output. And then we have 1, 0. And then we're going to get 1, 1. And lastly, we're going to get 1, 1, 0, 1. And so this is what our waveform should look like. For this part, it seems incorrect in the middle right here, because when we have 1, 0, our output should not be 1, 1. It should be 0, 1. I'm not sure if the actual truth table that we were given is incorrect, or if the actual waveform or code is incorrect. But it looks like everything is connected correctly, because we've labeled our inputs, and we've said that we have our inputs and our output wires here, and then we've connected it properly, where we have our first NAND gate up top, and we have it coming out as a Q, and then we have our S0, and that's one of the inputs, and our other input is actually incorrect. So we found the error, which is great. Found the error because we have NAND gate 1, and then inside of here we have S0 and then R0. Well, if we look at the actual circuit diagram we're given Q, we're given S0, and then instead of R0, the bottom input is Q0. So we're gonna have to change that from R0 to Q0. And let's double check our NAND gate 2 on the bottom. Our output is Q0, yeah. Our top input is Q, and then our bottom input is R0. So we fixed this. Our code is now 100% correct. So this is what it looked like previously. I'm just going to take a screenshot of it to make sure that we can compare it. We're going to need to recompile this. So we'll click Start Compilation. We'll click Yes because we want to save our changes. Override the bad stuff, and now it's going to redo this. We're only going to compile this, and after this compiles, we will remake our simulation. So before we do that, we have to close our current simulation, which is why I took a screenshot. So yes, we want to quit this, and then we're going to wait for this to compile. Alright, so that's compiled. We'll go to Tools, Run Simulation, and RTL Simulation again. Once we do this, our feather should pop up. ModelSim is here. And now click on Work. I think we're going to have to re-add everything, yep. So we go to Compile, click Compile, go up our directories. We're then going to compile this, and then we are going to compile this, and then we can click Done. Then we can go up to Simulate, click it. We're going to start the simulation. We want to expand our work. Click Test Bench, click OK. 0 errors, 0 warnings. So this is what it's going to look like. Now we can control and click all these and bring them into here. We'll click Run again right next to 100 PS at the top. We don't want to finish, so we'll click No. And then we can go back in here, and we're going to right click and then zoom full. So let's test this and compare it to the truth table. So at 0, 0, we should have 1, 1, which is invalid. It's good. And then at 0, 1, we should have 1, 0, which is good. And then at 1, 0, we should have 0, 1. And then at 1, 1, it's no change. So this is perfect. Our waveform works. It looks great. And now, well, we can say that we've done it. So this is the waveform for our lab, and we've done the Multisim earlier.